Saxon Algebra 2, Lesson 8. Greetings, students. Today we're going to start with a little vocabulary session. The word I want to talk about is polynomial. Polynomial is a big, scary word for a simple, easy idea. A polynomial is the basic unit of algebra. You've been using them for a long time and you're not scared of them at all. All right, what you are scared of is probably that name because it's a scary word. Polynomials always take this shape. That looks weird. What even does that mean, right? A is a real number, and we often call it a coefficient. Okay? So it can be any number. It can be a fraction, it can be a decimal, it can be a percent, it can be positive or negative, but it's just a real number. That's cool. This, as you know, is a variable, a letter. Right? We use letters in algebra. And this exponent can be a whole number. And you may think, well, of course, exponents are always whole numbers. Later, we're going to find that we can use fractional exponents, and you already know about negative, but those are not polynomials. Those turn into something else. So no negatives or fractions. We can use those, but then it becomes something other than a polynomial, okay? This is the shape of this basic polynomial, and like I said, we have more complicated shapes, but this is the basic. Now, sometimes we hook together a few of these basic dudes. If we have just one of them, we call it a monomial, and that means we have one term. We also talk about binomials, and that's when we basically have two terms, right? And we also have talked about, an example of this would be x plus 7. A monomial would be like, say, x. A trinomial is when we have three terms. Can't write 3, sorry. And an example of that would be x squared plus 7x plus 15, just to make one up, all right? So they're still polynomials when they're linked like this, but they have special names that describe their special qualities, all right? So these are all polynomials. They just have special names that we often refer to them by. We don't often say polynomials because it's such a ridiculous mouthful. But again, just remember that that's a big name for a simple idea. They're this units. We can talk about degrees of a polynomial. And to find the degree of a polynomial, we look at the degree of the highest. I feel this is something you say it and it's like, this is just talking in circles. It makes no sense. Let's say that we have an equation. Let's just use this one. X squared plus 7x plus 15. And someone asks you, what's the degree of this trinomial? Well, you look at the terms, you find out the one that has the highest exponent, it's this one, and you realize that the exponent is a 2. So this is considered a second degree polynomial. This always used to confuse me. What if you have x to the third plus x squared y to the fourth plus 7? This term, you combine the exponents. So this would be a sixth degree polynomial because you combine the highest degree of the highest degree term. So you combine the exponents. What we're going to talk about today is a first degree polynomial. Here, I'll slide this up a little so you can see better. A first degree polynomial with two unknowns. We actually spend a lot of time talking about this little fellow with a weird name that we've never seen before. But you know him as a line. The formula for this jolly gent is y equals mx plus b, right? We fill in the m with the slope, we fill in the b with the y-intercept, and that's how we find the equation of a line. It's a first degree polynomial because there are no exponents in any of the terms, right? They're just ones, right? In our variables. And it has two unknowns. So that's why we call it that fancy thing I called it at the bottom of the last page. Now, we spend a lot of time graphing lines. And there's two ways to do that, and one way is annoying, I think, and the other way is kind of fun. So I'm going to review for you both ways. The first example illustrates the annoying way. Graph the equation 2x plus 3y equals 6. The first thing we need to do, no matter which approach you're using to graphing the line, is we have to change to y equals mx plus b format. Okay, and we can see right off the bat that, yeah, this has got an x and a y and a plain number, but we don't like the order of this. It's not in the right format. So the first thing that we always do is change it to the y equals mx plus b format. That means we kick the x and the plain number to the right, and then we have to get the y by itself. So let's subtract the 2x. 3y equals minus 2x plus 6. Notice that I want to shape it with the x first and then the plain number, so that's why I put this in this order. Then we have to divide by 3. We don't let fractions bother us, we just want y by itself. Y equals minus 2/3 x plus, that reduces to 2. Okay, cool. Now we're in good shape. Now we can decide which strategy we want to use. And here's option 1. Make a table or a chart, whichever way you want to, whatever you want to call it. I don't like this way. I'll complain about it a little bit. Here's what we do. I make mine different than John's. In case you don't know who I'm talking about John Saxon, author of our text, our fearless leader, our savior from math textbooks all across the world. Okay, what we write in here is the actual equation that we have, right? 2/3 x plus 2. All right, so what I'm going to do is I'm going to choose some values for x that I think are going to be easy to calculate. and then I'm going to find out what the y's are, and then I'm going to graph those points. The thing about this is you have to be really clever because I don't want to make this fraction into a mess. I don't really want to be graphing fractions. So I'm going to do everything in my power to find numbers that will create whole numbers here and not fractions. So the first one I choose is 0 because I know that when I multiply this dumb 2/3 by 0, it's just going to turn into 0, right? 0 times anything is 0. So my y value just ends up being 2. I like that. We need to have at least 3 values here. 3 is my minimum. And it's also my maximum because I don't want to do extra work. Okay, now this denominator is 3. So I know that if I choose 3 for x, they'll cancel, right? So let's do that. Minus 2 over 3. And then I'm going to multiply it by 3. These cancel. Oh, and I have to write the plus 2. Now I just have minus 2 plus 2. Oh, look, that gives me 0 here. Huh, interesting. Well, I like the way that 3 worked out so much that I'm going to choose minus 3 for my third value because I know it'll cancel again. Something different is going to happen because I know my signs will do something weird, but that's okay. I just want the denominator to go away. Now I notice these turn into a positive. The 3's cancel, and so I get positive 2 for all of this. Then I add 2 more, and I get 4. All right. I can live with it, right? Now I'm ready to graph. If you have graph paper, use it proudly. There are Post-its, you know, the 3M people that make the official Post-its. They sell little graph paper Post-its, which are super nice because you can just work on your regular paper, and then when you get to a graphing problem, you can just smack a Post-it on your page. Those are really great, so check those out. I am okay with just drawing it on my paper. I use the blue lines for the y-axis, and then when I'm doing the x-axis, I just try to draw them about the same distance apart as the blue lines are. Okay, so, and I also say, do as little marking up of your graph as you need to make it neat and tidy. Your answers will be much easier for you to check against John's answers if you make them fairly neat and tidy. Okay, so now what I'm going to do is I'm going to graph these pairs of points that I created. 0, 2, 3, 0, and minus 3, 4. Hopefully those are going to line up. Hopefully I calculated everything right. And they're going to line up and give me a nice straight line. 0, 2. There's the first point. 3, 0. There's the second point. And minus 3, 4. 1, 2, 3, 4. All right, that turned out looking pretty straight. I feel good about that. And because I don't have a ruler handy, and you might not either, I just find something straight. That allows me to connect those dots. And that is my graph. And then just to be super precious, I write the name of the line next to it. Y equals minus 2/3 x plus 2. That's what I got up here, right? That's my answer. And when I check it against the answer in the book, I pay attention to 2 points. I want to make sure that the solution agrees with where I cross the x-axis and where I cross the y-axis. And I can see that the solution says cross the x-axis at 3, which is exactly what that is, and cross the y-axis at 2. So those are both correct. So I feel good about my solution. And I smiley face that puppy. All right, so that's how I want you to check your graphs. It's easy to just look at it and go, oh yeah, that looks about the same. But your line might be slightly misangled because of the imperfections of your graphing, and it could still be right. Or the line could look about the same, but you're crossing at the wrong point. So check your solution by checking those points. All right, so this is option one. This is the make a table or a chart, however you look at that. This is the way I like to do it. John does his sideways. He doesn't give himself room to work. I don't like that. My way's better. Sorry, John. I want you to feel comfortable with this because we are going to need to use this method later when we're graphing things that are not lines. So I want you to be okay with this, but once you're like, yeah, that's fine, I know how to do it, I want you to switch over and use what we call, John calls it the intercept slope method. I call it the slope intercept method. So potato, potato, but this is option two. You're remembering, I'm sure, whatever I write down, I want you to write down, right? Of course. Okay. The line that we're using is exactly the same line. 2x plus 3y equals 6. We have the same first step, get it in y equals mx plus b format. I like to just write that so I have it in front of my eyes. Remember, that's kind of my rule of thumb, is that as you're doing your homework, if the formula has already been written down once on a problem on that page, you can just use, you don't have to write it again. You can just reference the earlier time you wrote it. But every time you flip the page, you should make sure a formula that you're using shows up on that page so that it's right there where you can watch it. All right, so the first thing we want to do is rearrange. This is just like what we did last time. 3y equals minus 2x plus 6, right? I'm shaping toward that. I divide by 3. Well, what a surprise. Y equals minus 2/3 x plus 2. Now, this time we're not making a chart. What we're going to remember is that this is our slope, which is equal to, if it's positive, it's the rise over the run. And if it's negative, I call it the sink over the run. It reminds us that if it's the rise, we go up and then to the right. If it's a sink, we go down and then to the right. These are kind of blending together. Make sure they're separate things. All right? So this is the slope. It tells us where to go, but this tells us where to start. This is the y-intercept. We start here, and then we go to the slope. So let me remind you of what that looks like. Here's my graph. Again, I'm not putting in any numbers or arrowheads or anything until I'm sure I need them. I'm not numbering it. I like to keep my graphs lean and mean. So the first thing I want to do is go to the y-intercept. It's positive 2. This is the y-axis. I'll just jot that down. So I want to go to 1, 2. There is my y-intercept, and I put a big fat point there. Now I use the slope as a treasure map to lead me to the second point. I start using my treasure map from the first point. I don't start at the origin. Sometimes students want to do the slope first and think, oh, I'll just start at the origin. No, start at the y-intercept. You have to plot that one first. This tells me I'm going to go down 2, right? It's negative, so it's a sink. I'm going to go down 2, and then I'm going to go over 3. Down 2, and now I need some marks, don't I? Over 3. There is my second point. Now, connect the dots. And that's my line. And as you can see, that looks a lot like the line we had before. And again, the crowning touch is to write the equation of the line and indicate that, hey, this little line has a name and that's what it is. And this is correct. It looks just like our picture last time, right? It crosses at 3 and 2, which is exactly what we had here. 3 and 2. All right, so this is the slope intercept, or as John calls it, the intercept slope. I suppose his makes sense because he's saying do the intercept first and then the slope. I say slope-intercept because we call this the slope-intercept form. I'm talking in circles. It doesn't matter. Let's try another one. This was example 8.2 PS. 8.3. This is our last example for the lesson. Are you happy? Use the slope-intercept to graph y equals minus 3x minus 3. Well, all I have to say is thank you, John, because look, this time he gave it to us in the right form, so we're happy and life is good, right? Cut the drama. Okay, we remember we start here. Our y-intercept is -3, so we go down 3 on the y-axis. Remember, the y-intercept is always on the y-axis. I mean, that's kind of straightforward, right? We go down 3. That's our first point. Now we look to the slope to give us our treasure map. The problem is there's only one number there. It's not a fraction. I said the slope was always a fraction here, right? Either a rise over a run or a sink over a run. Well, we can make it a fraction. That's no problem. So now that tells me I want to go down 3 more. One, 2, 3, and then over 1 to get my second point. So this line is kind of weirdly off the center of our graph, but that's okay, it's correct. And again, I check it by seeing, okay, where does it cross the y-axis? Well, that's here at -3, that's right. And then John says it should cross the x-axis at 1. And that looks about right, doesn't it? That looks pretty good for mine. So I'm calling that a win, and I'm calling this a right answer, and I'm calling this y equals -3x minus 3. Okay, so the big takeaway on this one is if your slope doesn't come as a formula or a fraction, you can make it into one by just dropping a 1 under there. Is there anything else I want to tell you? Negative slope was a sink over a run. Yeah, I think that's it. All right, lesson 8 is history. Enjoy. Graphing lines, doing these things that we did in this lesson, this is at the heart of algebra. When people talk about algebra, this is one of the key subject areas that they expect students of algebra to understand. So if you get this, give yourself a pat on the back. If you don't understand this, please reach out to me and let me know. All right, and that includes my students who found me on YouTube but don't otherwise know me. You can reach out to me and ask me questions. You can find my email. You can search me out on Facebook if you want. Just email me, it's fine. But I'm happy to answer your questions if you have any. Okay, thank you, goodbye.